Hello again. Today we're talking about electrons, protons, and neutrons. Today your topic is electrons, protons, and neutrons. Instead of writing out the words, we could put these symbols. Typically when we talk about electrons, it's an E with a negative exponent. Protons is a P with a positive exponent. And then neutrons don't have anything next to it. All right, your goal is I can label and explain how many protons, neutrons, and electrons are in each element. So Henry Moseley discovered that every element has a set number of protons found in its nucleus, which we talked about when we talked about the history of the atom and how we came to know it. Well, from this he created something called an atomic number, representing the number of protons in the atom's nucleus. So every atom is neutral, meaning the atomic number will tell you the number of protons found inside of it, and that is the same number of electrons. And that's how we tell atoms apart, is by the number of protons. So first, protons are positively charged particles, help make up the nucleus of the atom, help identify the atom, which is considered the atom's DNA, equal to the atomic number of the atom, contribute to the atomic mass, and equal to the number of electrons. Okay, so you do need to make sure that you type protons and highlight it. And if you would rather underline these words than highlight, that's fine as well. And you do need to write down what is underlined right here. For space, you don't have to necessarily put it in bullet points if you just want to write it in paragraph form. However, you need to make the information fit. Neutrons. They are neutral particles. They have no electric charge, and they help make up the nucleus of the atom, and they contribute to the atomic mass. So you need to write neutrons and underline and highlight it, and then write down what's underlined in this box. Electrons. They are negatively charged particles found outside the nucleus of the atom. They're in things called orbits or levels, but we'll actually talk about that in a later unit. They move so rapidly around the nucleus that they create an electron cloud. Mass is insignificant when compared to protons and neutrons because they are actually extremely small, even compared to protons and neutrons. They are equal to the number of protons, and they are involved in the formation of chemical bonds. So when you see chemical reactions or chemical changes, that is happening because of electrons. All right, so you need to be able to identify different parts of the atom and what you can see on the periodic table. The different things you need to be able to identify is the atomic number, the atomic mass, the number of protons, number of electrons, and how to find the number of neutrons. So here you can see carbon. You have a smaller number, which in this case is 6, and you have a bigger number, which is 12.011. So the atomic number is the small whole number, which the number of protons is also that small whole number, and so is the number of electrons. So for carbon, the atomic number is 6, the number of protons is 6, and the number of electrons is 6. Now this bigger number that has a decimal is called the atomic mass. Now to find the number of neutrons, you have to do a little bit of math. Yes, I know that's horrible, but it's not that bad. You need to take this bigger number and subtract it by the smaller number. And I'm okay if you round. Now, just a kind of a reminder, if you're rounding, if this number after the decimal is less than 5, this number stays the same. If this number is greater than 5, then you'll add 1. Well, in this case, it's less than 5, so we can round that to 12. and 12 minus 6 is 6. So there are 6 neutrons. So if we look at sodium, the small whole number is 11. So our atomic number is 11. There are 11 protons, 11 electrons, and the atomic mass is this bigger number, 22.990. All right, so let's find the number of neutrons. So if we round, 9 is greater than 5, so this would be round up to 23. So 23 minus 11 is 12. So you would have 12 neutrons. Okay, now we're going to kind of break down what those numbers stand for and what they mean. So the atomic number is the number of protons in the nucleus of the atom. So you do need to write out atomic number, underline it or highlight it, and then the definition you need to type out is the number of protons in the nucleus of the atom. So if you look at this picture below, we can figure out what the atomic number is by counting how many protons. And here the protons are the circles with the plus sign because it has a positive charge. So 1, 2, 3 protons. The mass number. That is the total number of protons and neutrons in the atom's nucleus. It is expressed in AMUs, or atomic mass units. That's just kind of the unit they give it. Each proton or neutron has a mass of 1. So here, what would the mass number of this atom be? So you need to count up your protons and your neutrons. So here we have 1, 2, 3, 4, 5, 6, 7. So here it has a mass of 7 AMUs. Why do we not account for electrons when calculating the mass number? Well, that's because electrons are so small. They have very little effect on the mass itself. So in reality, it doesn't matter how many electrons you have. It's not really going to change what the mass is.